In this video, I want to have a look at finding the areas of composite shapes that involve rectangles and triangles. So if we have a look at it, just to jog your memory, the area of a rectangle, if we've got its base and its height, the area is just found by multiplying the base and the height together. If we have a triangle, we know its base and we know its perpendicular height, so it's really important that it's its perpendicular height, which means the height and the base meet at right angles. Then the area of that is going to be a half times the base times the height. So in these area of composite shapes questions, there's always lots of different ways you can go about it. So when you're doing these, I want you to really have a think about different ways that you could answer it and then deciding on which one you think is the most efficient. So let's have a look at some examples. All right, so in this shape, we've got this L shape here, and we want to find the area. Now there's three different ways that I can see of doing this. There's probably more. So we're going to run through all three of those and show you how they still all get us to the same answer. So the first way that I see is if I split this shape straight, that's the wrong button. If I split the shape straight down here, and then I can find the area of this rectangle and the area of this rectangle and add them together. So if I do that, this is my first method of solving this. To find the area of this rectangle, I would do 7 times 17, which would give me 119. And to find the area of this rectangle, I would do 6 times 13, which would give me 78. So to find the total area, I would have to add those two things together, and I would get 197 meters squared for the area. Now, my second method, rather than splitting it down here, if I had split the shape across here instead, then I've got one long rectangle on the bottom and this shorter one up the top. So to find the area of this long rectangle down here, I'd have to know the whole length of the base, which would be my 13 plus my 7. So that whole length along there would be 20. So this rectangle would be 20 times 6, which would be 120. And this smaller one up here would be 7 meters across, and we need to know how tall it is. So we know that the whole shape is 17, and we know that this section here is 6, which means that from here to here, this section has to be 11. So the area of this section up the top would be 7 times 11, which is 77. And then to find the total area, again, we would add them together, which would give us 197 meters squared. The third way that I can see of doing it is rather than breaking the shape down is to build it up. So if I were to look at this whole big rectangle all together, then I could find the area of that by doing 20 times 17, which would give me 340. And then I could subtract this bit that's been cut out of the corner. So the area of this section would be 13 along the base and a height of 11. So 13 times 11, which would give me 143. And then this time, instead of adding them together, we'd subtract them. So we'd go the area equals 340 minus 143 to get 197 meters squared. So when you're solving these, you only need to do one of these methods, but it is really important that you're looking for different pathways to get to that answer and then deciding on which one you think is going to be the easiest and the most efficient. Let's have a look at a few more examples. For our second example, we've got this shape here. Now this shape is a trapezium, and later on we will have a look at finding the area of a trapezium using a particular formula, but for now I want to treat this as a composite shape. So I want to break this into a rectangle and a triangle. So this is my first method of doing it. I would break it across here. So to find the area of this rectangle, I would do 18 times 15, which would give me 270. And then I need the area of this triangle. So because it's a triangle, it's going to be a half times the base, so along here, which is our 15, times the height. So we need to figure out the height of this triangle, so from here down to here. We know that the whole length of that side is 38, and we know that this section is 18, so that means this distance, or the height of our triangle, is going to be 20. So we'll have a 20 in there, and that will give us 150. So to find the total area, we would add those two areas together, and we'd end up with 420 centimeters squared. The second method that I can see for doing this is, again, instead of breaking the shape down, is to build it up. So if we looked at this rectangle as a whole, I would do my base times my height, so 15 times 38, which would give me 570. And then I can find the area of this triangle and subtract it. So that triangle is going to be a half times its base, which is that 15, and the height we already figured out was 20. So 15 times 20, and we did that calculation up here, was 150. And this time, because it's been cut out, that triangle, we're going to subtract instead. So our area would be 570 minus 150, which would give us that 420 centimeters squared. All right, our last example is this rectangle here that's had a triangle cut out of the bottom. Now again, there are lots of different methods you could use to find the area of this one. But in this one, I think one way is definitely the most efficient way of doing it. So what we're going to do is we're going to find the area of that whole rectangle and then the area of the triangle and subtract that. So the area of our rectangle, so we're going to do this one all in one go this time. The area of our rectangle would be 50 times 20. And I'm going to subtract the area of this triangle, which would be a half times 17 times 14. And if we pop all of that in our calculators, we're going to end up with 881 millimeters squared for our area. So again, looking at areas of composite shapes, I want you looking and thinking about the different pathways that you could take and choosing the one that you think is going to be the best for that question.